Hey everyone, today I am excited to show you a project that mirrors the internal workflow of top AI labs like OpenAI and Anthropic. We are building an RLHF preference labeling and data export tool. Okay, if you heard of models like GPT-4 or Claude, you know they are incredibly helpful and safe. But raw language models don't start out that way. They require reinforcement learning from human feedback, okay, which is known as RLHF, to align their responses with human values. In this video, I'll walk you through the problem this tool solves, the architecture behind it, and how it acts as a bridge between raw LLM and generation and downstream reward modeling training. So, what is the problem we are trying to solve? Okay, when we train a language model, we want it to follow instructions accurately, safely, and helpfully. But how do we teach a computer what helpful or safe actually mean? We do this by training a reward model, a separate AI that learns to score LLM rewards based on human preferences. To show a prompt that two different responses, like response A and response B, must pick one is better. Okay, without a specialized annotation system, collecting, managing, and structuring this pairwise data at scale is incredibly slow, prone to format errors, and difficult to validate. That's where our platform comes in. Our solution is a complete containerized full stack data engineering pipeline. Here is how the system architecture works. Coming to the phase one, which is seed generation. Like we start with a data set of prompts across five key categories like factual QA, creative writing, code generation, summarization, and reasoning. Okay, a seed script calls an LLM twice with different temperatures to generate two distinct responses per prompt. If offline, the script falls back on high quality pre-generated comparison templates. Like coming to the phase two, the main annotation loop. The annotator uses our web interface. The backend automatically tracks which pairs have been labeled, fetching the next unlabeled pair of the specific annotator to prevent redundant work while calculating inter-data agreement rate. Coming to the phase 3, which is data export and validation. Once labeled, the data is transformed into standardized JSON lines, okay, which is JSON format, matching the exact structure required by alignment trainers. A downstream validation script verifies the file before feeding it to the training loop. Okay, coming to the tech stack I used, like which is developer friendly application. First, for backend API, we use Fast API in Python. It's extremely fast and supports automatic OpenAI documentation. And coming to the ORM database, SQL Alchemy connected to a production grade PostgreSQL database. And coming to the front end UI, we used React powered by White and styled within a custom vanilla CSS dark theme. Okay. And coming to the orchestration, we use Docker Compose to handle multi-container environments, set up database volumes, and run health checks. Okay, let's discuss about the working process. Here we have the labeling workspace. It has beautiful dark mode interface. You can see the instructions prompt at the top and response A and response B side by side. Annotators can evaluate the options and click on their preference or use our keyboard shortcuts. The A key for response A, B for response B, T for type, and S to skip the prompt. Okay. And submitting a preference immediately fetches the next pair, keeping the workflow seamless. Okay, next is the analytics and inter-rater dashboard. Here we track the total annotations, label distributions, and the inter-rater agreement rate. If multiple annotators label the same pair, this calculates how often they are, which is critical for measuring dataset quality. And finally, we have the data export page. We can filter by categories like code generation and download our labels.jsnl file. Each line is a clean JSON object containing the prompt, the chosen response, and the rejected response. Okay, let's Like for running this project is incredibly simple. All you need is Docker installed on your machine. First copy .env.example to env and fill in any case if you want to use live LLM generation. Then run this command in your terminal, which is docker compose up -fn build. This builds the React app, pulls the PostgreSQL image, initializes the tables, seeds to 50 prompt response space, and starts the web server. To run the downstream validation scripts on your exported dataset, just run python downstream slash validate data.py labels.json and it will confirms if the file is ready for your training runs. Okay, and that is the RLHF preference labeling and data export tool. By combining a clean fast API backend and interactive React frontend and robust data validation, we built a tool that solves the critical bottleneck of human preference collection. Thank you so much for watching. All code is documented and ready in the repository. Okay, the link is attached in the description.